And welcome back, students, as we get into another lesson on binary files. We're going to kind of start wrapping stuff up here, though. Today, let's discuss binary input and output of objects and also the serializable interface. So, getting started, you can output objects of classes you define as easily as you output int values using write_int. And you can later read the objects back into your program as easily as you read int values with the method readInt. And we've seen this in our last two lessons. So for us to be able to do this, though, the class of objects that your code is writing and reading must implement what is known as the serializable interface. So interfaces is going to be a topic that we talk on in a later chapter. But for us to talk about the serializable interface, it's pretty easy to use and pretty much doesn't really require knowledge of how interfaces work. All you really need to do to make a class implement the serializable interface is to add the two words implements serializable to the heading of the class definition, such as in the following example: public class person implements serializable. And that's it. Pretty easy. So the serializable interface is in the same Java.io package that contains all the other I/O classes that we've discussed in this chapter. So for example, in some class, we're going to define a demo class that implements the serializable interface. Now let's just flip over real quick to Eclipse to show you that. So if I go to some class here, you can see I import the serializable. And I have public class, some class, and you can see down here I just have a private int number, private char letter, public some class, so this is my constructor, setting it number to 0 and letter to A. Public some class, int the number, char the letter, number is equal to the number, letter is the letter, so again more constructor methods, and of course we have a toString method. Now we will explain the effect of the serializable interface later, but first let's just see how you can do binary I/O with the serializable class, such as this class, SumClass. Object I/O demo illustrates how class objects can be written to and from a binary file. So if we want to write a object of a class such as SumClass to that binary file, we're simply going to use the method writeObject of the class object output stream. We can then use writeObject in the same way that we would use other methods of the class object output stream, such as writeInt, but you can use an object as the argument. So if we go back over here, you can see again SumClass implements serializable. That's the key thing right here. And so then we look at our object I/O demo. You can see, of course, it's importing all our streams that we were familiar with from before. And this is, of course, a binary I/O of the serializable class. So in here, it's going to, of course, have our object output stream. So it's going to create this data file. It's going to create some SumClass objects here, one object and another. It's going to write those objects out to the file, close the output stream. We have our I/O exception catch. Then down here, it's going to attempt to read in that file. So here, it's going to read in the class objects to read 1 and read 2. And from there, it's going to read those back in. So it's going to do print line, so it means it's going to call the toString method. All right, and of course, we have our catch statements here. So I'm just going to run this real quick. All right, data sent to file. And now let's reopen the file. Let's play the data. The following were read from the file. Number equals 1, letter equals A, number equals 42, letter equals Z. All right. And of course, those were defined right here with our SumClass objects. All right. So pretty straightforward on how that works. And you also, of course, have the read object in here. Read object was, we have our write object and read object. Write object being right here, output stream.write object, and of course down here is our read object. Read object being what we use to get it back. So if an object is written to file with write object, then it can be read back out of the file with read object of the stream class object output stream, also illustrated in our object I/O demo. The method read object returns values as a type object. So if you want to use values returned, that's a typo there, returned by read object as a object of a class such as SumClass, you must do a typecast as shown in the I/O demo. All right, and of course you can see here is the typecasting right here, SumClass. All right, let's talk a little bit about the serializable. So a class that implements the serializable interface is said to be a serializable class. So to use objects of a class with write and read object, the class must be serializable. But in order to make the class serializable, we change nothing in the class. All we have to do is add the phrase implement serializable. So if you look at these classes here, for example, object I/O demo, there's nothing that has really changed about this class, except for this class. Obviously, it says right here, implement serializable. that's the only thing. So if I were to, let's say, if we flash this back to programming 1, for example, where we had the person class. All right. So in the person class, if I wanted to make the person class serializable, I don't have to change any of the code. All I have to do is just add these two words right here, implement serializable. It's that easy. Now what this phrase does is it tells the runtime system that it's okay to treat objects of the class in a particular way when doing file I/O. Therefore, if a class is serializable, Java assigns a serial number to each object class that it writes to a stream of type object output stream. If the same object then is written to stream more than once, then at the first time Java writes only the serial number for the object and not a full description of the object's data. This makes the I/O much more efficient and also help keep your files a lot smaller. Because let's face it, if it's pretty much the same object, why would you need to repeat the data when you just need to have like, hey, this is what it is, and it can pretty much like in effect say, hey, we have a previous instance of this object. I can just look at the other object to get that data. Now, when read back with a stream of type object input stream, duplicate serial numbers are returned as references to the same object. Now, the key thing to know what this means is that if two variables contain references to the same object, and you write the objects to the file and later read them from the file, then the two objects that are read will again be references to the same object. So really nothing in the structure of your object data is lost when you write the objects to the file and later read them back. So it's kind of a nice thing about the serializable interface. It doesn't change anything of what we've done up to this far. It's all of a sudden like, oh, we made a totally new concept in programming. Now everything you know is thrown out the window. No, all you're really doing is you're adding one more tool to your toolbox to really kind of help with file I/O. All right, let's discuss those class instance variables. So when a serializable class has instance variables of a class type, then the classes for the instance variables must also be serializable. And so for all levels of class instance variables within classes. So a class is not serializable unless the classes for instance variables are also serializable. So you might ask, well, if we can serialize everything, why can't we? Well, it's very simple. Security reasons is one of the biggest things. The serial number very much makes it easier for programs to get access to the object data written to secondary storage. Also, for some classes, it may not make sense to write objects to secondary storage because, well, they would be meaningless, and you read them out later. So, a quick example, if the object contains system-dependent data, the data may be meaningless when later read out. So, let's say you are pulling data specific to one machine, it's read, and let's say it stores it on like a flash drive. Well, then you move that to another computer, and then let's say that could be your first one was, let's say, Windows, well, second one's Mac. Mac has a different filing system. It's going to have some issues. So, those are just a quick examples of how something like that might run into it. Alright, so another thing to discuss is this pitfall here, mixing class types in the same file. Now the best way to read and write objects using object stream and object input stream is to store only data of one class type in a file. So pretty much all ints are in one file, all doubles are another, all strings are another, all object types are in another. If you store objects of multiple class types, or even objects of only one class type, mix in with primitive type data, well, your system can get confused and you can lose data. We kind of mentioned about this, when we talked about reading numbers back in. If it's not knowing what the next type is going to be, it's going to come back as gibberish. All right, and our last thing to kind of wrap us up here is how to discuss handling array objects in binary files. Now, if you kind of recall, an array is an object. It's a collection of different data types. So it could be a collection of strings, collection of chars, collection of int, etc. So therefore, it makes it a very suitable argument to use things like write object for. Now, an entire array can technically be saved to a binary file using write object and later read back in using read object. Now, when doing so, if the array has a base type that is a class, then the class must be serializable. So you can't use a non-serializable class in the array for this instance. This means that if you store all your data in one serializable class in a single array, then you can output all your data to a binary file with one invocation of write object. Now, this way of storing an array in a binary file, of course, has been illustrated for us within the array IO demo. So if I'm going to pop over here real quick, here's array IO demo. Close this so we don't have to look at output. All right, and of course we have our usual input and output streams up here. And you can see I've made a very simple array here. So it's just a one-dimensional array of size 2. We have our first object set to some class 1 and A. A1 is some class 2 and B. It's going to output that and close the stream. Then it's going to, of course, write to the file and it's going to attempt to reopen it. And it should then, here, you'll notice the following array elements are written from the file, so it's going to print out the array for us. So if we run this, all right, we get array written to the array file. We have it reopening it, and then here, right here is where it's going to read out. So here's our number equals 1, letter equals A, number equals 2, letter equals B. Again, remember these right here are two-string method calls, right? And then end the program. All right. So really nothing that we haven't kind of seen before. This, of course, is just a very basic print array method. It's going through each iteration of the array indices. And that's really all that's to it because it's just an array. I mean, you don't have to really handle it any differently than what we've been doing. One thing that we do want to note is that the base type sum class is serializable still. Right? And that is kind of important here because if it's not serializable, it could make our life difficult. You also notice that the typecast will use the array type sum class. Now, because readObject returns its value as an object of type object, it must be typecast to the object type. All right, and this is a common thing you're going to have to come into if you start handling like unique classes, is that you're going to have to make sure you don't just try to use it normally because it's going to try to come back as an object. Even though, yes, they are technically all objects, it's the object class. So you got to make sure that you typecast it to the appropriate class. So if we're going back to the example, if you had a person class, you'll need to typecast it to person. All right, and that's going to wrap up this lesson for today, folks. I believe we have a really quick conclusion coming up here fast on our chapter on I/O, and before you know it, we'll be on